Hey Precalc students, welcome to the 5.4 notes, day 1. If you looked at the pre-lesson notes, we did a lot of review on how to factor quadratics and how to solve quadratics. So today we're going to kind of transition from quadratics and just algebra to quadratics and trig. The most important thing that you have to remember with quadratics and trig is that you need to make sure that whatever you're factoring or whatever equation you're trying to solve, that they use the same function throughout the entire expression or equation. So make sure that no matter what, you're looking at, if you need to transform something that you've been given so that it's written all with the same trig function, okay, within each problem. So if you look at number 1, the trig function they're working with is tangent. Everything has tangent. They didn't throw in a sine somewhere, a cosine, or a cosecant. So you're good in that sense. Now, this is very similar. So I want you guys to notice there's a quadratic term and there's a linear term. All the quadratic terms in trig are written like this. So that's the same as 2 tangents multiplied. Just the same way we would write x squared was x times x. We do not write tangent squared like this. Because if we were to write it like that, that means they're taking a tangent of an angle theta and multiplying with the angle itself. So this guy right here, tangent of theta squared, is not the same as tangent squared of theta. So I want you guys to notice that. We have talked about that in class. I believe somebody brought it up before. Okay, so we have a quadratic term and a linear term. One has a coefficient of 2, the other one has a coefficient of root 2. We did problems like this in the algebra pre-lesson. So this is similar to having 2x squared plus root 2x. Do you notice that they both have an x, or since we're factoring? Your job is to always check for GCF. So the GCF of these two expressions, just like it was over here, right? This was x. These each have tangent of theta as a GCF. What you take out goes in front, and then your remainders go in the parentheses. So I'd be left with a coefficient of 2. I had 2 tangents of theta, right? It was a quadratic. I took out 1 tangent, so that's tangent theta that's left. And then here, the tangents of theta cancel, and we're left with root 2. Similar to this guy, factor out the x that they had in common, you'd be left with 2x plus root 2. You know that you're done factoring once you have linear terms as factors. So tangent of theta is a linear term because it's to the first power. Okay, next example. Good news is they're using only secant, so we don't have to worry about rewriting anything to get everything to look to use the same trig function. So I want you guys to notice they have secant of theta squared. That's the same thing as secant of theta, like that. Okay. This is similar to x squared minus 8x plus 12. So our secant is x. And actually, this is not theta. I completely am blanking out on how to say this. I don't know if it's phi, but it's a Greek letter. You are more than welcome to change it to theta or x. Doesn't matter to me, okay? But if they want me to factor this, since this is a quadratic term, this is a linear term, and this is a constant term, this is a quadratic trinomial, I need to try to find two numbers that multiply to 12 and add to -8. Pause the video and find those two factors. The two factors would be -2 and -6. So if you remember, we would factor this as x minus 2 and x minus 6. We're going to do the same thing here, except for instead of x, we're going to use secant of your variable. I don't remember, it's phi or phi. Oh, I'm so disappointed that I forgot how to say that. Okay. Now, this is the factored form of that quadratic trinomial. You are more than welcome to distribute those to prove to yourself that it really does, in fact. So secant of phi or phi times secant of phi or phi gives you secant squared, and look, I'm already changing it to theta. Secant of that Greek letter times -6 is -6 secant of that letter. Here's your -2 secant, and -6 times -2 is 12. And if you combine like terms, you get -8 secant of that Greek letter. Okay, kids, it was driving me nuts not knowing how to pronounce that Greek letter, so I Googled it. It's phi. Okay, so we factored that quadratic trinomial as secant of phi minus 2 times secant of phi minus 6. And like I said, you could FOIL it, distribution, combine like terms, and you see that it does actually factor to that. Remember that factoring changes what a problem looks like. It changes it into multiplication. It does not change the value. So you could even go back to number 1, distribute tangent of theta, and you'll see that you do get the original 2 tangent squared theta plus root 2 tangent of theta. The hardest part about this lesson is going to be transitioning from algebra to trig. Okay, number 3. Good news is they're using only one trig function, which is great because that means we don't have to transform it in any way. You should notice that you have a quadratic term, a linear term, and a constant term. So this problem is similar to 2x squared plus 1x minus 1. Pause the video and factor this quadratic trinomial of 2x squared plus 1x minus 1. Push play when you're ready and you have it factored. Okay, I got 2x minus 1 and x plus 1. If you guys need help with factoring, it is super, super important that you guys use your online resources to just YouTube or Khan Academy and look up ways to factor quadratic trinomials and find a method that works for you. Like I've mentioned before, every teacher has their own strategy. My strategy may not work best for you. Some people learn guess and check, but it is super crucial for you guys to know how to factor these. Okay, now remember the x in the example I gave you is really cosine for this problem. So this one, instead of factoring to 2x minus 1, it's 2 cosine beta minus 1 and cosine beta minus 1. You can distribute that. Oops. To convince yourself that this, in fact, does give you the original expression. So it would be 2 cosine squared beta minus 2 cosine beta minus 1 cosine beta plus 1. Combine like terms. You get 2 cosine squared beta minus 3. Oops, see? This is how I know that something was wrong. This was supposed to be plus 1. Aha! Do you guys see it? I had minus 1. But because I FOILed it, I realized I made a mistake. So if I change that here, plus 1, there we go. It gives me the negative 1 cosine beta and the negative 1 over here. That's why I really like factoring quadratic trinomials, because once you factor it, you should be able to check and see if it worked. So I had a plus 1 on the right side, but I put minus 1 by accident, and when I multiplied it, I realized I did something wrong. Feel free to do that anytime. Okay, next one is also a quadratic trinomial. Now, I forgot to mention this earlier, but number 1 had a GCF. Number 2 did not, neither did number 3. Number 4 doesn't either. Yes, the first two terms have a GCF of 4. But remember, GCF, the C means common, greatest common factor, and not all 3 terms have a 4. So I can't say that 4 is a GCF. Okay, now here, this one is similar to, so we're going to treat sine x as just our variable x. So this would be very similar to an algebra problem of 4x squared minus 4x plus 1. Go ahead and pause the video and factor 4x squared minus 4x plus 1. Push play when you're ready. Okay, once you have it factored, you can go ahead and write your factored form, but remember the x is really sine. So sine is the variable x. So you're going to write 2 sine of x minus 1 and 2 sine of x minus 1. You could also write as 2 sine of x minus 1 quantity squared because there's 2 of them. But this would be okay. Again, the most important thing you need to be doing here is transitioning from algebra to trig. Okay, notice that the directions for number 5 are the same as 1 through 4, except this is where I remind you that you need to make sure you write everything in the terms of one function. Now, because these are quadratic, notice sine x squared is quadratic, you're often going to use the Pythagorean identities that we learned about. Now, sine squared comes from the Pythagorean identity that says sine squared theta plus cosine squared of theta equals 1, or cosine squared of theta plus sine squared of theta equals 1. So, if I solve for sine squared, you can see that I can replace sine squared with 1 minus cosine squared. Why am I doing that? Because I want this expression to contain only one trig function. And since I have sine and cosine, and there's no identity that relates cosine to sine except for the Pythagorean identity, that's the one I chose. Okay, so now I have only one trig identity. Notice that this is a quadratic trinomial after I combine like terms. Now, when it comes to factoring, your leading coefficient shouldn't be negative. So I'm going to go ahead and divide all of those terms by negative 1. And then I'll be ready to factor. So I'm going to divide out a negative 1. That will give me cosine squared x minus 2 cosine of x plus 1. with a negative out in front. So again, these two are equivalent expressions. It's just a factored form. So when you take out a GCF, it can't disappear. Remember, I don't want math magicians, I want mathematicians. So the negative 1 is still there. Okay, I now have a quadratic trinomial. So I'm going to go ahead and ask myself, how is this related to algebra? Here, cosine is going to be like my variable. So this is similar to x squared minus 2x plus 1, where the x is your cosine. So cosine squared x is your x squared, minus 2 cosine x is your minus 2x, and then plus 1. Okay, this factors to x minus 1 and x minus 1, or x minus 1 squared, because there's two of the same ones. Either one of those is correct. Now remember, x was your cosine. So this guy, that's what I'm saying is the hardest part, transitioning from algebra to pre-calc. That would be an acceptable answer, or you can put negative 1 parentheses cosine of x minus 1 quantity squared. Remember, you can pause, rewind the video at any point. Feel free to send me a message through Remind, and I can make up another problem for you to practice, but it is critical for you to know how to factor quadratic expressions involving trig functions. Okay, continue and watch the second video to watch the second part of these notes. It's actually a review of things that we learned in Chapter 4. Okay, good luck.